Okay, so what we're going to do is we're going to program your calculator with the program called Euler, which is to use Euler's method. Now they often will give you questions in an exam where you either need to do Euler's method by hand or use a calculator, and they're going to assume that you have a program that you can use. Now there is one in your TI as well, but I'd like you to program this in so that you have this option. I think this is really easy to use. So we're going to go through all the instructions here together. So if you get your CAS out, and hopefully it's charged, we can put all this in. So I'm just going to move this to the side and we can do this together. So what we're going to do is we're going to open up a new calculator page. This is just the one I had from before. And I'm going to go new page, just a blank one. I'm going to go now, once I've got a blank page, go to menu, go all the way down to functions and programs, and program editor. You're going to do some coding, so you're going to be typing some instructions in for your CAS to follow. We want a new program, so it's going to be menu 911. We're going to call it something. I'm going to call this Euler, and because the new CAS has an Euler, I'm going to call it something else. I'm going to call it Euler, I could call it a number, like Euler 0, Euler 1. I think I already have an Euler 1, so I'm going to call mine Euler 2. Okay, so once you have this up, what we're going to do is we're going to follow the instructions here, just as they are. So it's already got define Euler. I've just called mine Euler 2. And we're going to type in exactly what it has here. So x1, comma, y1, comma, c, comma, h. What those things represent, x1 is your initial x, y1 is your initial y. C is the value that you want to get to. Okay, so it's the x that you're getting to, and that will tell you how many terms you're going through. And then h is your step size. All right. Now that will have, you might have to scroll along just to check what it has written after that. It has an equal sign and then program, which is what this is. It's saying this is a program. Now we're going to type all the rest of this in. We literally type in the word local, space, n, comma, x. That's telling us the variables we're going to be using. You press enter to go to another line. x1 is going to be stored as x. The arrow is store. So I've typed x1, then control, var, to get the arrow in, and then x, and press enter. x1, we're going to, same thing, store a1, and then the square brackets. And I'm typing it, so it's a bit easier, but the square brackets are down here, control, left bracket, and then you can pop the 1 in. Remember that control left bracket is the quick way of getting your square brackets up for vectors too, so it's handy to know that shortcut. Enter again. Now we're storing our y, we're going to call that b, so control, var to get the little arrow, b1, and again control, left bracket, a 1 in there. Now what this is doing here is giving us, these are basically like subscripts, so a1, b1, and they're going to change. You know how when we did this method by hand you had like you had y1, y2, y3. So down here further on you can see where that action is going to happen. You see the n plus 1? This is like our y n plus 1. So the y is b, the a is x. They just store them as a's and b's instead of x's and y's in here. So it's a bit easier to deal with. So next line, 0, storing that as n, enter, display. So you can literally type DISP. It's also in menu in the catalogue, but just type it, it's quicker. Now this bit here looks funny. You've got a space and then you've got your quotations. Now the quotations, whoops, are going to be living in here. Control multiply. Okay, control multiply's got little quotations. Now we're going to type X and then we're going to put some spaces in, yeah? So I'm just pushing the space button. It's a few times. What that's doing is it's going to print, disp means print, so something's going to print over here. It's basically going to print this out as a column. So if you actually remember how many spaces you put in here, that's going to be how far apart these will be up here. And we're going to do something down here as well with a bit of spacing. So you probably want the same spaces. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8 spaces. Okay. And next line, same thing, disp, space, x1, comma. Again, we've got control multiply because you've got the little things here. Put your spaces, 1, 2, 3, 4, 5, 6, 7, 8. I just did the same number. a comma, and y1. What this is telling your calculator to do is put out the x that it finds, bit of a space, and the y1, and it's going to keep doing that. So you're going to get like a table with x printed and then all the values under it, and y printed and all the values under it. And you can fiddle with this to make it pretty once we've put it together. Now this next part here is a loop. It's what's called a while loop. So while something is happening here, while x is less than c, that means while the x value is less than the one you wanted it to finish at, it's going to do the iterative method that we did. It's going to go round and round, adding a value to n, doing what we did. So you'll find that that bit is familiar there. And then it's going to repeat it. It's going to go round and round and round and round, increasing and increasing x until it hits the x that you specify as c. And once it hits that x, it's going to end, and then it'll end the program and you'll get a pretty picture come out. So here I'm just going to put the while, and we literally type everything. n+1, control var to n. So you know, this kind of method of automation is really cool. If you are interested in it, you can automate a lot of the processes that you do with a CAS. And write programs to do that for you. So that's something we can look at towards the end of the year. If any of you are interested in doing that, we can certainly do that because it can make some of your processes a bit quicker. And it's all just typing, H, storing. Now if this doesn't work, it's probably because you've typed something wrong somewhere, or maybe you've put a space in where there shouldn't be a space. So you want it to look exactly like the picture that you've got on your page. So A1 n+1 stores as x, and this part here is telling you that it's going to display the new x, so the n+1x, comma, control multiply, put some spaces. I've put 8. Now these, it might look funny, so you can change it when you have a look at what it looks like. B1 square brackets n+1, and then we type end while, which tells it to end this loop of going round and round till we hit C, and then we end the program. Now actually it already has that in there, so you don't have to type end program again. So that's it. So what you want to do with this is you want to make sure that you've done this correctly. Oops. So once you think you've finished typing, go up to menu and go to the second option. It's called check syntax. Syntax is the language you're using. So it's basically saying, does this thing make sense? And then if it does, we're going to store it. So check syntax and store. And you can see here it says Euler 2 stored successfully. That means you've done this right. So it makes sense. If you've done something wrong, it will give you an error. So we should be able to use Euler 2 now. So what we're going to do is actually use it for the example that we did first up, which was this one here. So where our derivative was cos x. Okay, so what you need to do is you need to do some defining. Okay, now the reason for that is, can you see sort of a bit down here we had this gx happening here. We hadn't actually told the program what gx is. So you have to define gx. Gx is the derivative. So I'm going to type in here g of x, and it's my derivative. So I'm going to define. So you can either use the dots, this control matrix button, and define it this way, or you can type define. So g of x is going to be cos x, and push enter. So now when you do g of x, it knows that that's cos x, and the program now knows that too. Now in this example here, we had initial values given and we had a step size. Now for this program to work, we need a few things. So we're going to type it in, Euler 2, that's the program, it recognized it, it made it bold, bracket, x1 is the initial x, it's 0, comma, y1 is the initial y, that was 1, comma. The next thing here is a c. Now c is the x that you want to get to. So remember that when we did this by hand, we were looking for y3. Now for y3, the x value would be 0.3 because it's 3 steps up. 1, 2, 3, h is up. So because h is 0.1, the third x that we're looking at stopping at is 0.3. So in our CAS, we'd actually put 0.3. That tells it we iterate 3 times. And h, which is the last thing up here, is our step size, which is 0.1, 0.1. Now we push enter. Now you can see what's come out, and it's so pretty, is this table, and this actually is the same table that you had here. Check it out. The 0, 0.1, 0.2, 0.3, and the 1, the 1.1, the 1.1995, and the 1.29751. So you can actually do this, you know, a lot further. We did this 3 times, and you're probably over it after the 3rd time. But if you wanted to look at solutions further than that, you know, I'll do just on the next line here. Let's say we want to go to 0.8. So that's 8 iterations. So see how it gives you that big table, and you can see here when we started at 1, it starts to get closer and closer here to sort of 7, maybe it's going to go to 8. So it's probably approaching 2, realistically, is where this is going. So you can do this a whole bunch of times, and you wouldn't want to do that by hand, but you can automate it. So using the CAS, you can use your program Euler, or in my case Euler 2, to use Euler's method. Now what you want to do here is you want to make sure that you save, so Control Calculator, save this as something. You might like to call it Euler Program for Spesh, something like that, just so you know. And when you go into your exam, you want to make sure that you open that document up so it's sitting there. So if you've got an Euler question where you need to use this, you can open it and make sure that you define your function g of x. If you don't do that, your program will not work. So that's using your calculator to program Euler's method.